This video is going to go over the rules and procedures for testing capacitors, replacing them, and out in the field manufacturing the capacitor you need with what you have on your truck. First thing you're going to do is you're going to need to know where to set your tester. Your tester will be set to the microfarad rating, which is the MFD. I'll do that now. Now, do not use an analog tester where you look for the spike. That does not work. That's not the proper way to do it. Get a tester. If you're going to do this, get the right tester. You need a tester that will test capacitance. The reason for that is it's extremely important that you are within your 5 to 10% parameters in order to protect your compressor and your motor to make them work properly. Right here I have a 40 microfarad capacitor. To test it, it's very simple. All we do is we put either lead on either terminal. This one is giving us a reading of 39.5. Now, if you will refer to your supercool, you will notice that a capacitor must test between 10%, it can be over by 10% or under by 5%. So we had a 39.5. I'm going to set that here, 39.5. Now, a 40 microfarad capacitor, 10% over, all you do is you multiply your 40 by 1.1 to represent your 10%. So 44 on the high side, 5% on the low side. 5%, we are looking at multiplying 40 by 0.95. So we must be between 44 to 38. Now we had a reading of 39.5, so this capacitor is good. Now, if I'm out in the field, let's say I'm out there and I need a 10 microfarad capacitor, and all I have on my truck, let's say, are a bunch of 5s. Okay, so with a bunch of 5s, we are going to, let me get the correct ones. What we're going to do, we're going to manufacture a 10. So to do that, our motor calls for a 10. All we have on the truck are a bunch of 5s. We do it in parallel. So to wire these capacitors in parallel and get a microfarad rating of 10, this is what it will look like. You'll have 2 jumper wires. They will be done parallel, just like this. If we're unsure, don't know if you did it correctly, take your tester, just go on one capacitor and check both leads. Doesn't matter which one. I'm going to check this one in the back. We're going to be looking for 10. We get 10.5. So we'll take our 10.5. Once again, we need to be plus or minus 10%. So on the 10% on the high side, we'd multiply 10 by 1.1, which would give us 11. Multiplying 10 by 0.95 will give us 9.5. Our capacitor tested out at 10.5. We're within parameters. We are completely fine there. So this was manufacturing a 10 microfarad capacitor with 2 5s that were on the truck. Now let's say we needed a 3 microfarad capacitor, and on the truck we don't have a 3, of course. Nobody carries a 3, but you do have a 7 and a 5. And actually that 7 is going to be a 7.5. 7.5 and a 5. So to come up with 3 there, instead of wiring them parallel as we did here, we're going to do them in series. The easiest thing to remember here is just we're going to use 1 wire instead of 2. So if we'll take one of the wires off, using a 7.5, there's only 1 jumper in between the 2. Now, to test this, I have to test it out here, which is where we're going to have this, where we should have the 3. So I take my tester, put it on the unused terminal, on the other unused terminal. We're at 3.3, which is within the 5% under or 10% over. It's actually exactly 10% over, so we're good there. That was manufacturing a 3 microfarad with a 7.5 and a 5. Last but not least, you're running this all the time. You're out in the field, you need a dual run capacitor. All you have is a lot of single capacitors. So this is going to represent, this is our dual run capacitor, and it's blown. Here's my Herm, here's my fan, and over here is my common. Okay, so this one is blown. This one was a 40 and a 5. So we're going to take a 40. And a 5. All we do here is we just mark, it doesn't matter, you can mark either side. Mark one side Herm, the other side common. On the fan, just mark one side fan. The other side, of course, will be common by default. So you're going to have to add one jumper wire. This is what you had before. Use a jumper to represent the common. This will go back to the old common. The other side is going to be your Herm, and with the unused side will be your fan. So we started with 3 wires. Right now we've got a fan, we've got a Herm, and we've got a common. We are right back to 3 wires, and we made a dual run capacitor with 2 separate capacitors. The other thing is anytime you replace a motor, if you replace a motor or you replace a compressor, always replace your capacitor. Doesn't matter how old it is. Replace it, start with a new one. Thank you for watching the video on capacitors.
Hello, I'd like to take a minute to introduce you to the coolest tool in the HVAC industry. Historically, technicians have carried 4 or 5 different slide rules. You have one for R22, one for R410A, one for metal duct sizing, one for flexible duct sizing, and yet others for diagnostics or troubleshooting. Thankfully, those days are gone. This one tool will allow you to charge a system with R22 or R410A in either the superheater subcooling method. The back cover contains required formulas. It has capacitors, rules, and practices, a wet bulb conversion chart, how to perform computations on series or parallel circuits, an electric heat strip guide, a complete system troubleshooting diagnostic chart, and how to troubleshoot compressors in TXV. Inside is packed with even more information. It performs sizing of both metal and flexible duct. It has the only direct reading conversion from smooth metal to insulation lined metal we've ever seen. The majority of technicians have never been taught that if the insulation is on the inside of the ductwork, you cannot size it with a regular duct calculator. It has step-by-step directions for determining airflow through a gas furnace, electric furnace, or an air conditioning unit. It has pressure drop multipliers for ductwork, as well as recommended velocities. And finally, the scanning of this QR code gives instant access to over 100 tutorials to assist the technician with every test and repair imaginable. You owe it to yourself, as well as your customers, to own this tool. It's less than $20, including shipping. The Super Cool will save you countless hours of frustration when troubleshooting units. Log on to our website and get one today, and I promise you will be a better technician tomorrow. And remember, every technician is only as good as their tools. Thanks for watching.